Yesterday we have seen matrix multiplication. Yeah, up to here. Next one is broadcasting. For example, let's take that I have array. Put numpy. Five. Array 2. Array, let's take 6, 7, 8. I want to apply mathematical operation, addition. It is giving that operands could not be broadcast together with shapes 5 and 3. So this has 5 values, whereas in this case, this has only 3. So if it is in an irregular shape, the shape doesn't match, then it is not possible to do operations like this. So there is a way that we can, come out of this. Let's take that m, right? np.new access. So instead of having it in one dimension, we can convert this into a higher dimension, that is in this case 2 dimensional, and then we can concatenate this two. Now you can see that we got the data, right? So in case if you if this is what the requirement is, if this is fine to convert from one dimension to another higher dimension, then go for this. So any questions on broadcasting?
Sir, could you please explain one more time? It's not clear to me.
Yeah, so thing is that array, usually this colon means like when we have an array. So there's something called row slicing and column slicing. So rows means I need all, if I need all the rows, then I'm going to use colon. If I want to introduce a new axis, new dimension, here what happens is, because of this, a new dimension has been created. So every value it has been wrapped in square brackets compared to this original data set. This is one dimensional and this is two dimensional. It has been converted from one dimensional to two dimensional. So if these two arrays are in irregular shape, so you can see 3 values and 5 values, it is not possible to apply concatenation or addition. In that case, introduce a new axis in the column thing, and then we can concatenate. We'll discuss slicing in a short while. So, any questions on this part?
Sir, new axis is for column itself or row?
Yeah, it's for column.
So for every column value, that array 2 will be multiplied. Added.
It's going to add one more dimension to every values.
Okay, it will make equal that one columns and rows. Is that it?
It's not going to make it equal columns and rows, but usually there's going to be only one column, right? So 1, 2, 3, 4, 5 is only one column. It's only one column. Once it
yeah, understood that np.new axis, but plus my array 2 is there, right? I didn't understand that.
So this my array 2 is 6, 7, 8. So as we can't concatenate or add when it is in irregular shape, we have only 5 values, whereas in this case we have only 3 values. So we can't concatenate. So we get an error, something like this, 5, 3. That is when we can introduce a new dimension. So instead of one dimension, we can convert it into two dimensional, and then we can concatenate it. So it's 1 plus 6, 7, 2 plus 7, 1 plus 7, 8, 1 plus 8, 9. Same way, 2 plus 6, 2 plus 7, 2 plus 8. This one. 3 plus 6, 3 plus 7, 3 plus 8.
Yeah, okay. Individual elements will be added for the next my array 2.
Yes.
Yeah. Got it.
All right. The next one is reshape. Let me take an array. For
Column
example,
side slicing or row slicing will only give particular rows and columns, right?
yes, but here in this case, we are not specifically fetching a chunk of data. We are fetching all the data, but introducing new access. We'll discuss in detail about slicing later.
Okay.
So let's take that I want to take some random values. Let's take 100 values. The 100 values here. So I'm going to assign it in a new array. If you look at this, it's 100 values. If you look at the dimension, it is one dimensional. Look at the shape, it is 100 comma. This is one dimension only. You will have a rows, right? So it's going to be, it's not even rows and columns. It's only flat 100 values. Suppose if I want to convert this into a 10 comma 10, two-dimensional array, then I can reshape the existing array. Instead of creating a new one, I can reshape this to 10 comma 10. You can see now, let me assign it to another array 2. If I check dimension, let me display the data first. You can see it's a two-dimensional array, right? So if you check dimension, it's two-dimensional. If you check shape, it's 10 comma 10. So we can convert a one-dimensional to a multi-dimensional or to whichever shape that you want. But the fact is, one thing you need to keep in your mind is, so 10 multiplied by 10 should be equal to the values that we have. So here we have 100 values, so 10 multiplied by 10 works. 20 comma 10 doesn't work. Let me do this. Let's take 20 comma 10. 20 comma 10 is 20 multiplied by 10, that is 200, but we have only 100 values. So it will throw error. You can see that it throws error. It has to be compatible. So let's take 20 comma 5. It's 20 comma 5 is 100, right? It works.
20 rows, 5 columns,
20 rows and 5 columns.
5 columns.
Or maybe you can say 50 comma 2. No, it has the multiple, when we multiply these two rows and columns, it has to get back to its original thing. That is how we need to reach.
Size of that one, yeah.
You should not give a incompatible one.
So
Right.
the random values will always be between 0 to 1 or maybe different?
Here you can see it's not 0 to 1, right?
It is,
So basically, the
is
set
there
of
a range
values,
for random values?
we can give the range. We can give the range. So I think yesterday we discussed in detail about it. I think in this random it doesn't support. Maybe random 1 comma 100. 100. Let me check what it says. Okay. This case generating 100 values. np.random.rand about this. About this. Yeah, it's 1 comma 100 comma, let's take 100. You can provide the range, but not all methods supports.
So the step function is not there in the rand int, right? Only like specifying how many elements are needed, that's it.
We can add step by reshaping it. So to some other method. So let's take, we can do that. So that's not difficult.
Okay, so got it.
The next one is slice. Sorry, yeah. We have seen converting from one dimensional to multi-dimensional. So we have seen it here. And now, if you let's say that my array 2 we have, right? If you want to convert this back to one dimensional, right now This shape of, let's take, let me get back to this original form, 10 comma 10, right? So 10 comma 10. Now, if I want to convert this back to one dimensional, I have something called ravel. Please mute yourself unless you want to raise questions. So you can see the ravel is going to again convert it back to one dimension. If you check NDM, it is one dimensional. If you check shape, it is 100 comma. So the ravel is opposite to of reshape, right? We converted one dimensional to multi-dimensional by using reshape, and ravel is going to flatten out the array. So it's going to remove all the dimensionality part. It's going to make it one dimensional. Of course, we can assign it back to another array altogether, right? So, any questions on reshape and ravel?
No, sir.
We
So
already
this
have this.
ravel is same as 1 into 1, right? I mean the original.
Yes, yeah, one dimension, not 1 into 1, one dimension. Right now, if you check shape of this 10 comma 10, 10 comma 10, right? If I apply transpose, that is capital T, is going to convert in rows into columns and columns into rows. If you check shape, of course, this 10 comma 10 doesn't make much difference unless you see the values. 1.23.83, this is 1.23.87. If you go with another shape, let's say 20 comma 5, 20 comma 5, its dimensional shape is 20 comma 5. But if you look at transpose, the shape of it, you can see 5 comma 20. So transpose converts rows to columns and columns to rows.
So this is short form of reshaping like that. T.
No, not the reshaping, but transpose converts rows to columns to rows. Of course, it changed the dimension. It changed the rows, the way the rows
Inversing.
and columns. Yeah, not inverse. The matrix. Okay, when we say inverse is going to be different.
Okay.
Inverse
It
is
changes
different.
this row
Transpose.
values to column and column to row.
Yeah,
But in
rows.
reshape we can give our custom values. I mean whatever the rows are there.
Whatever the shape that we want to convert, it can. Any other questions on that? Next topic is very important. So I already have my array 1, right? So let me delete the other part. Slicing is very important, so stay focused.
So
Even
is there any practical example where we have used this one just to see the example other than this problem?
yeah, so we will see that in projects. So you are not going to directly transpose the data set in any manner. But while analyzing the data, if you want to, I know, suppose if the data has been come in a way that rows to columns to columns to rows, there is necessary that we need to. Suppose if we have data set, let's take that all the indexes in fact need to be columns and columns need to be rows, but we read the data in a inverse way. I mean, in a transpose way, an opposite way. Then we can apply transpose, but usually we don't get such scenarios. In pandas, we have the same transpose. If in case the data comes in that form, then we can transpose it. Otherwise, not really required. Most of the data comes in an order.
So if I get the value in the form of list without using NumPy, is there a way to convert it into array?
Without
NumPy.array. Yeah. Without using that library, there is no way, right, to convert list into array.
which array you want to convert to?
I mean, if I will create an array called A or something, I will put some 10 values. Using the NumPy library, NumPy.array, I will pass that A into this one. It will be converted to this one, right?
Yes.
So without using this NumPy.array, there is no way to convert that list into array. Is there a way?
Basically, your question is you want to convert to NumPy array without using NumPy array.
Yeah. No, only array. Is there a way? Like that.
No, which array?
Normal array. I mean, if I write your
In
NumPy.array, it
Python,
will come in the format of
in Python,
array.
in Python I call array as list. But which array
Array
you
to,
are specifically saying?
when we get the output of the NumPy array, it will give it as array of here in that line number 10 or something after that one. It has
Okay.
written array of some list, right?
Okay.
So without using library, can we convert this one? Or
So
this is what
that is
NumPy
the
library
point.
is.
Yeah, that is what you're saying. So you are saying that you want to get a NumPy array without using NumPy array.
Yeah.
No, we have to use NumPy, NumPy array.
I mean, I told without using, is there a way? That's it. I mean, the library is for that only. Like,
Yeah,
yeah.
got it. But without using NumPy array, you can't get a NumPy array.
Okay.
At least even without using NumPy library, we can't get anything that is related to NumPy. All
Okay,
right.
sir.
Yeah. So the next one, maybe in pandas, we have the option to convert pandas data frame to NumPy array, but internally it's going to use NumPy array again. All right, the next one is we have NumPy array. It's one dimensional. Suppose if you want to, let's take that in this cross section, suppose, let's take, you need to get only this data, right? Then, I mean to say only chunk of data, only some part of data. Then we use slicing. Of course, slicing in square bracket, we have to mention square brackets. What is row slicing? First, we need to apply row slicing and then column slicing. So basically, row slicing means inbound, and we need to mention the outbound. Outer bound is not going to get inclusive, so we have to usually add +1. The same case for column slicing also. So we have something called inbound and outbound. Same in the case of Python list, right? But in this case, we need to apply both, on rows and columns. First rows, and then you need to move on to columns. Suppose if
So
you
for the
want
column itself, same, right? -1. I mean, the column what out last bound will
yes,
not be included.
+1, +1.
Yeah, +1. Oh,
Yeah, same case +1. So, so if you want to fetch all the rows, we need to mention colon. But if you want to fetch all the columns, then you need to mention colon. My arrays, what happened? A two-way index. Oh, sorry. So this is one-dimensional array. So let me reshape it to 10, 10, and let me assign it back to this one. Right now, I want to fetch only chunk of data. Let's take this particular chunk. Let's see how we can do that. So it is, if you want to fetch all the rows and all the columns, we can simply mention it's colon colon. Of course, even without it, without this, you're going to get the same data set. But if you want to specifically extract some chunk of it, but in this case, I have taken example 0.123, right? So we need to cross check which row. First of all, we need to start with the row slicing and then column slicing. So we need to find out which rows all these rows will fall under. So what is point? Where is point 1 to here we have, right? Which row will it fall under? So
third row.
third row, right? Okay, third row to third, fourth, fifth, sixth, seventh, isn't it? So third, fourth, fifth, sixth, seventh. But thing is, third row to seventh row, but outer bound is not going to get included. So we need to add +1, that is 8. So let me check this one. So we got 1.12. Is it 0.12?
So that is not 7, sir. That is 4th
Yeah,
row, I think.
sorry,
You have taken the 4th itself.
4 itself. Third, fourth, fifth, sixth, and seventh, right? All right. So let's see. Maybe I
1.477
think
is in the 4th row itself.
no. I think the way the rows has been shown, but the idea is third, fourth, fifth, sixth, seventh. All those rows I need, and the columns perspective, it is my array 1. It is 1, 2. So third and fourth columns I need. Third and fourth columns. So third and fourth columns, it is 3. it may not exactly match because the way the data has been shown, it is not completely showing up, right? It's not completely filling it. The idea is 0.12, so it means that third row to seventh row and third and fourth columns. Third and fourth column in sense, obviously from index perspective, it is 2, right? And fourth column. So index perspective is 3, but outer bound is not going to get included. So it's 2 comma 4. So this is the intended output that I'm expecting. This case, so it may not match because it has to
Yeah.
spread out the whole row into this line. Only then we can get a chunk properly. So first row slicing and then column slicing. So wherever the data that it falls, so we need to look at how many rows it got expanded. Make sure that outer bound is not going to get included. So add +1. And if you want to reach till the end, you can ignore the last part. Or if you want to start from scratch, you can ignore this part. You not to mention 0. You can ignore that part.
So we can only mention the row and not the columns, right? It will be
Already,
give the entire row value.
I've already
We have
mentioned.
to use the comma.
Yeah. You can, if you need all the columns, you can mention this column.
Yeah.
Yes.
Entire from 0 to 8 it will come.
Yeah. So you're going to get all the columns, but only up to 7th row.
7.
Any other questions on slicing? Practice it more. If you don't understand it, so you'll definitely get a good understanding of it. So take a small set of data. Take tab. Maybe in pandas it will be much more clear. So the same concept will get repeated in pandas too. Fine. Any questions on slicing? The next concept is Boolean indexing. So let's take that same myArray one. I'm not going to use this one. I'm going to use a simple one-dimensional. Here we have a bunch of negative values and positive values also, right? We have negative values. Do we have positive values? Yeah. Here we have positive value. Suppose if I want to get only positive values in this, we need to write a comparison operator on this, greater than or equal to 0, right? Maybe I will consider greater than 0. So there is no such thing as 0 here, precise 0. So I'll go with greater than 0.
It will give true false.
Yeah, it will give Boolean values. But we can pass this condition. So I'm going to write it as condition. We can pass this condition in array and we get the actual value. So we have only positive. Do we have any negative values here?
No.
We don't have any. So the same case for negative values. So if I want to get only negative values, of course I can get it. So based on the condition we provided. 1 second. Right? And we call this as Boolean indexing. So these are set of Boolean indexes. It's going to generate indexes, but in a true false manner, Boolean values. So we pass these Boolean values to the directly to the array, and it's going to generate where and it's going to give us the values wherever it is true. So false will be ignored by default. If you want to, let's take that you based on this condition, these are a bunch of negative values, isn't it? We can pass it even in this way, tilde. For example, in this condition, we have all the negative values because the condition is as such that we want to fetch only the negative values. Suppose if you need an opposite way, you can see that we can use tilde or tilde. So that it is going to act as an opposite thing, not of. What?
So if the condition is for positive, it will give the reverse of that.
Exactly.
What is the tilde?
Yeah. So if it is positive, obviously, so I'm not going to simply write as condition. This is going to generate only the positive values, isn't it? So let me remove. So you can see that. And if you as tilde is going to be all negative. So is there any positive values in this?
No.
So tilde is going to be sometimes it's going to be very handy. Suppose if you want to extract both the case as different chunks, right? Suppose I need all positives. So in this case, all negatives, right? But I want to write all positives also. then I can store it in this way, right?
Rather than writing the condition, we can just use that symbol
Right.
and get the value.
Instead of writing all the conditions, another condition altogether, we can do that. There's nothing wrong in writing another condition, but we can do this. Any questions on Boolean indexing?
No, sir.
All right. The next one is np.where. Suppose my array, right? So my array one. Okay. So suppose if I want to fill all the negative values with 0 or maybe NaN, null value. NaN is basically not a number in Python. It's numpy, pandas, or whatever. So it basically indicates null value also. Okay. So if I want all the negative values to be filled with what is that? Array one. So fill with since first my array greater than 0. It's my array 1 or 0. You can see all the negative values being filled with 0. Interestingly, if you look at this all positives and negatives, the shape will get changed, right? Only it will have compared to this original one. But in this case, the shape will not get changed. It is going to return all the 100 values. But interestingly, it's going to fill all the negative values with 0.
So the condition which we have written is from the rows and columns, give me only positive values, right?
This is the condition. The condition could be anything. If
Uh-huh.
this is true, reflect the values from this one. It's going to be on each index space. So each value is going to check. If this is true, then it's going to fetch a value from this. Otherwise, if this is false at a particular value, then it's going to reflect as 0. Let's say that I want to make it as -1. You can see that we got all -1s for all negative values.
So the first argument is condition, second value is the value, third one is the replacement of the original value.
Replacement of the version was. The advantage and the way we need to, it is going to be helpful when you don't want to disturb the original size of it, original size of it. Yeah. So you can even mention another array also if you have anything. So in that case, if this is false, these values will get reflected. And this will get reflected only when this is true. So that's how it works.
So the other matrix should also be of the same dimension, right?
Yes, of course, we have to. If we take two arrays together. Yes.
So this slicing and everything is used for extracting the data from the Excel sheet like rows and columns. Is it that way?
If you need a subset of data, and if you don't want all the data, then we want to use that. Yeah, go ahead, Sirisha.
Sir, can you scroll bit up here? If the first condition is false, I want to replace my array to as like a -1 like that. I mean,
I think we already did it, right?
no, you wrote it for my array too.
No. We have already written and we got this one. So we have seen an example on this.
No, what I'm sorry if you have already update. I mean, if I have already teach, but if first condition my array is greater than 0, then I want to. Okay, okay, understood. Okay, sir, got it. Okay, thank you.
We can replace with any other value for all the negative values.
I mean, the question is if first can I mention my array 1 in the condition and my array 2 can I use as a second parameter?
This one, so in that case, it doesn't. Yes, we can do that. There's nothing wrong in it, but doesn't make much sense. Yes, of course, you can do that as long as the shapes are the same. You can do that.
Okay.
Sir, the syntax, there will be some explanation, right? Is there a shortcut to know that one?
Yeah, it's a within round bracket shift tab.
Shift and tab?
Yeah, shift tab. To give the documentation.
Only 3 arguments, sir. Condition and array and that replacement value.
Yes. Any other questions? All right. The next one is mean median. Suppose I have an array, right? My array 1. I'm going to take the same thing. If I want to, let me take a simple one rather than making it complex. Take a simple one and p dot mean. We can take average of all the values. What is the average of 1, 2, 3, 4, 5? So 1 plus 2, 3. 3 plus 3 is 6. 6 plus 4, 10. 10 plus 5, 15. 15 by how many values we have? 5. So 15 by 5, which is 3. So it has to reflect 3. Let's see. We got 3. In the same way, we have median also. Median is going to give us the middle value. So what is the middle value in this 1, 2, 3, 4, 5? It is 3, right? But mean and median is going to give it's going to return the value in float form. That is straightforward, but if it is column wise on a multi-dimensional array, let me take this one. Let me take this whole data set, my array 1, right? Let me display this one here. So my array 1. Here it's one dimensional. Let me reshape it to, let's take 10, 10. And assign it back to this. If I want one dimensional back again, I can use Ravel, right? So we have this one. So np.mean, if I apply on array, is going to give the complete average. So all the values by number of values, that is 100. But if I need across rows, is across rows. If I need across columns, it's across columns. So 0 is across rows, and you can see that for every row, whatever the values that we have, it is going to give us the average of this. Let me take this average. Let's see what happens. My array 2 np dot array. I take np dot mean is going to give us the whole average, right? 0.67. It is matching, isn't it? So maybe the preciseness of it may change, but it is the same thing. But it's going to give us for every row as such. Like,
So what is that axis about? If you put 0?
0 is, you can see that. Okay, it's actually it's going across columns. And if it is 1, it's going across rows.
Sorry, 1 is for rows, 0 is for columns.
Usually 0 is for rows and 1 is for columns. But if we mention this, it's going to give us across columns. And it's going across rows. See that?
But the default 0 is for rows, right?
But usually it should be 0 for rows and 1 for columns. But you can cross-check the outputs rather than relying on this. Even pandas, there are some glitches that if it has to be in 0 for rows and 1 should be called for columns. There are some glitches that you need to check the output and then you decide.
I mean, we'll get the entire row values. I mean, the average after one.
Sorry?
Mean will get the entire row average value, right?
So that when we directly apply without any access, then it's going to give, irrespective of the dimension, it's going to average out all the values.
So what is median?
Median is going to give us the middle value.
Middle.
Same thing, yeah, middle value. Suppose if I have 22, 23, 24, 25, 26, what is the middle value here?
24.
If we have, let's say 27, then what is the middle value?
0.5, 24 point.
24.5, right?
Yes.
Because we need to average this out, 24, 25 average. Right, the next
So
one.
mode is not supported. Mean, median, mode is there, right? I mean, what is?
We have dedicated method for this statistics. We will discuss that in statistics. We have a dedicated library for it. Even Michelin template, we are going to see that.
NumPy supports modal. I mean, is there?
No, there is no direct supports. Even the mod different statistics. We have a library called statistics. We will see that later.
Okay.
Sort arg, max, and argmin. Let me take an array. Let's take 3, 1, 4, 8, 7. So I'm taking the array in a unsorted manner. Array 1. If I want to sort it, that means it's been sorted, but let's cross check. Let's say it has been sorted, right? So we can sort those values in this manner. What if I mention -1? Same thing. Yeah. And there is something called argmax and argmin. So I'm going to take the same data frame, some same
For
compare.
increasing to decreasing, is there a way in sort itself, like
There
descending
is
or
a reverse method, so we can apply reverse. I think the NumPy array doesn't have, then we can use minus array and reverse. There will be some
so we
other
have to use after the sorting, we have to use this one, right?
Yeah, so we can apply directly over there, or else we need to assign it back, basically. Only then it will get affected. All right, so any questions on this sort?
No, sir.
I'm going to take the same array, but in this case, what is the max value?
8.
8. So what is the corresponding index for it? So np.argmax
5.
will give us the index of the max value. So 1, 0, 1, 2, 3, 4, 5. So it's going to give us the 5. The same way, it's going to give only the index. Okay. So the same way we have min also, argmin. It's going to give us the minimum value. Here, what
So
is
we have to return it back to the my array to get the maximum or the minimum value again.
not the value, the corresponding index of the value. So
So
in
if I
this
return
case,
the np.argmax, it will return a index, right?
index
So
of the max
using that
value.
index, yeah.
And in this case, we got 1 not because it is 1, because it is at the index 1. 1. Let's take that I have 2, 1. We can see that we got 2 because at the index 2, we have the minimum value out of all these values. Of course, we can pass this to NumPy array and to get the actual value. Same way for this one. So let's pass this one to this. We get the max value. And you not to bother, like you not to use this one. Instead, we can directly have that, right? Same way we have
So
minimum
this will
also.
just return the value itself.
Yeah, it will
Rather
return the
than
value itself. The argmax is only when you need the index of the max or whatever main minimum. So any questions on this part? The next one is I'm going to take I'm going to explain stacking and splitting. I'm going to take an array. I'm going to take two-dimensional array. 3, 4. And I want to take another array. Same form. 5, 6, 7, 8. We have two arrays, right? Suppose if I want to combine this into one array, right? So we have something called head stack, wherein we need to pass arrays. We got error because when we provide, in this case, we need to provide in the form of a list. If you look at this, it has come one next to another horizontal stack. 1, 2, 3, 4. Basically, if you print my array 1 and my array 2, see We are placing horizontal stack means we are placing one next to another, right? 1, 2, 3, 4, 5, 6, 7. Suppose if I want one top of another, we have something called V stack. 1, 2, 3, 4, and 5, 7, 8. So basically, head stack and V stacks are for to combine arrays into one. Now you can see that interestingly it is two-dimensional. Any questions on this?
No.
I'm going to store it in head stack and V stack. So there is something called head split also. Head split. I'm going to pass head stack, and I want two numpy arrays. Now you can see that this is this list of arrays. So this is one list. This is another one list. So if you check 0, this one array it matches exactly my array 1, right? Same way we have this one 5, 6, 7 second array. So basically the idea is once we have hash tag, we can split back again to this form, but we need to be careful in providing this one. Suppose if I give 4, it's going to give me 4 arrays. Now then it will become like 1, 3, 2, 4, 5, 7, 6, 8. But suppose if you need it in vertical stack form, then you need to go with this one. Right? We have, and here I'm going to make it back again to 2.
What is the function of that split? What it will do?
It's going to split back again. So basically, we converted, we combined two arrays into one.
It will
And then
reverse
again,
that.
it's reverse process.
Okay.
V stack. That's the reason I have stored it in V stack and S stack. I need to provide how many arrays I need. So 1, 2, 3, 4, 5, 6. So we got it back again, right? Of course, there is nothing wrong in applying it. That is what your requirement is. We can apply it, but in order to show you how we can combine two arrays into one, and again how can we convert that one array to its original form. Any questions on this part?
So in practicals, everything just we have learned, it will be used, right?
Some way or the other it will be used. So it doesn't mean that we have every method, every property that we use it here need to be used. But some way or the other it will be used. We don't know what form of data that you get. So you should be in a position to handle any kind of. It's not like a method and then a project again, and this method another project. It doesn't work that way. Right? We need to learn with simple examples. Wherever it's necessary, we need to use it. Some cases, the methods that we explain may not be used, but in real time it may be used. So we don't know which form of data that we take, right? But then is another one, concatenate. The same thing. So my array 1, my array 2. So we need, I think, we need to provide in the form of tuples. You can see that we can combine this 1, 2, 3, 4, 5 series, right? You can see that. Suppose by default it acts is equal
V
to
stack.
horizontal.
It's like V stack only, right?
Yeah, the same horizontal stack. Sorry. Yeah, vertical stack. And this one is horizontal stack. So concatenate it does both head stack and V stack. That's why you need to provide this vertical stack, this 0, and horizontal stack it is 1. But you need to provide in the form of tuple, round bracket. I hope this is clear.
Yeah.
The next one is view and copy. Suppose I am going to take an array, dot array, okay, and I'm going to take another array. I'm going to take the same copy, okay. Want exact copy of it. We discuss this concept in ease, Python ease concept. If you remember it, it will be quite easy here. So my array 3, I'm going to assign the same my array 1. So if you look at the values now, it's my array 1, my array 2, my array 3 are the same. But what we done here is basically based on reference. MyArray1 internally in memory is going to be, those who know by reference and by value, it's not much difficult. So MyArray1, it has its own object, and array2, it has its own object, whereas array3 is going to refer this one, myArray1. So whatever the changes happen here will reflect here. Whatever the changes I apply on this, anyway, it's going to refer to the same object. So myArray1 will also get affected. For example, if I apply any operation, let's take plus 2 equal to 2, right? If I check myArray1, I have made changes only on array1. So did I make any changes on myArray2? It will not get affected even if you check it. So because these are completely isolated one. What about myArray3? As this is by reference, as I have made changes to this one, so this will also get is going to have the same set of values, right? Suppose if I made any operation against, let's take multiplied by, it's going to apply multiply by 2 all the values. If I check myArray2, it will not get affected because it has a separate object altogether. And if I check myArray1, it has been changed, right? But fact is that I applied operation against myArray3, not array1. As this is by reference, not by value, it will, it has been affected. So any operation that I do against 2, let's say I'm adding all the values to 2. So it has been changed, right? But myArray1 and myArray2 are going to be as same. So you can see that 6, 8, 10 it was, and 6, 8, 10 it is now. But if any questions up to here?
No, sir.
Especially those who are from Java background, C++, they are not going to have any difficulty with this. It's just by value by reference. If you want to assign a NumPy array like this, and without by reference, instead you want to have its own object, then use copy. I'm going to re-execute this again. Same values. Now in this case, myArray1, myArray2, myArray3 is same, right? I'm applying, I'm adding 2 for of each value for all the values. Now it is 3, 4, 5, 6, 7 instead of 1, 2, 3, 4, 5. What about array2? Anyway, it is a different object altogether, so it's not going to get affected. What about array3? It is still 1, 2, 3, 4, 5 because it is going to create another copy altogether, even though I copied from my array1. So that is the advantage of using copy. Any operations, irrespective of what
So
you
it
do.
is creating its own memory.
Yeah, its own object. It's not memory. Anyway, memory will be allocated, but it has its own object in the memory. It's not by reference anymore, it's by value. Right? So my array1, my array3 are totally different. So you applied our operation against my array2, and it's not going to get affected. Right. So that's it on NumPy. We'll start pandas tomorrow. If you have any questions on today's session, let me know.
Sir, I have this question like in the matrix will be there.
Hmm.
And the square bracket 0:3, comma 0:3. So
Okay.
for the row and row, what will get in that? Any matrix example?
So 0 is to
0:3.
Okay, you mean to say 3 rows and 3 columns.
Yeah, colon 0:3, comma 0:3. In the square bracket itself.
Slicing. You are applying
Yeah,
slicing.
slicing.
No, we
Yeah,
can't apply mat. We need to create matrix and then
Yeah,
slicing, right?
already created matrix in that one.
Okay.
If I apply this one, so how will it work? 0 to 3, 0 to 3.
No, we can't apply 0, 3, 0, 3.
Not
here,
comma 3.
Slicing.
Yeah, this one.
Which
on
one?
the matrix. On the matrix. Already created matrix.
Okay, right. So got it. So you're saying that 3 rows, 3 columns.
Yeah.
1, 2, 3.
So you have created one matrix, right?
4,
I mean
5,
the 10 into 10, 10 into 10 matrix for the my array 1 or something.
We'll take a simple example. So instead of
okay.
So 7, 8, 9. 3 rows, 3 columns, right? Yeah, 3 rows, 3 columns. My array 4. 3 rows, 3 columns. So my array 4. Let's take that I want only 5, 6, 8, 9. Then in that case, let's see. It's the rows. It's one row up to at the end, and same way one column up to the end. 5, 6, 8, 9. Only this part I need. So cross section 5, 6, 8, 9. So first row, it starts with first row until the end. Anyway, I know to mention it, even though but 2 is outbound is not going to be included, so we need to mention 3. But anyway, we need till the end, so we get that. We can do that.
So the first one is it is selecting the first row and everything, and second is column. From the second column, it is selecting everything. Is it
Yeah,
same way?
yeah. The cross section part we get it. So 5, 6, 7, 8. This cross section part.
Sir, what is a seed method?
Seed is like when we discuss, we can when we, especially when we generate random values, we use seeding. So in order to not to get disturbed, so if you want to get the same set of random values, we use that. In TensorFlow, we'll discuss that, and even in machine learning template, we'll discuss seeding. That is when we're going to use it in real time, not in NumPy or whatever.
Oh, that was my doubt, sir.
Any other questions?
I have related to this one package and module. So related to that one, NumPy is a package or a module? Package, right?
It's a library package, but basically module in the sense when it has a bunch of modules, we call it as package.
So with respect to numpy.random.randint, in NumPy is what there? Package module.
NumPy is a library or package. If it has
Okay,
more
so
than one module, then we go with we call it as package.
so random is a module.
Random is a module, yes.
Yeah. Okay, super.
All right, that's it for today. Thanks. Thanks for joining.